which is creating the interaction loop. So the interaction where you print the stuff and give a move, give the ability for the player to move, give the ability for the computer to move. Let's make that. A very nice way to do a state machine in BQN is with the native while, or the system value, system2 modifier while. Again, this will want two functions, one which returns if the while loop should stop. 0 is stop, 1 is continue on, and the left is just getting the value which is passed through the while loop and modifies it in some way. We can use header matching to find states. So if we pass around a string, for example, we start this thing with the start string, then we can match on that with a header match. And if we, for example, show hello here and go back to start again, return after that start again, then this will start printing hello very constantly. But we can also give back another string. So for example, after start, the computer will make a move. So if we return the start and here the computer move and run this. Oh yeah, and we need to do a semicolon if you're doing a new block. Then it'll go to one, then the other, with the one, then the other. So you can see how you can create a state machine here, where the last string you return is gonna determine what the next block is that is gonna be called. And here we just want to match on the end or not match. So if we go to the state end, then this will become 0, and the while loop will end, which means the game will end. So here we can create some nice interaction loops. So at the start we want to print some hello message. Hello, today we are going to play Tic Tac Toe. And then we will, we call that the print statement, which we defined before here. And then do a delay of, for example, 1 second. So I did hello, we're going to play Tic Tac Toe. And then print I'll start. So the computer starts. And then after that we're going on to computer move. So computer move will show or print. Here we're gonna reset the thing again. Here my move. And then the computer needs to make a move. So for the computer to make a move is quite easy. We're just gonna get a random value of the size of the field. So rand.range over the shape is this one. Yeah, the shape of the field. This will give us back an array with the 3 and the 3, which is the size, and then we're going to get a random value. We're going to store that in move. And then we need to see if the move we did is valid. So if the position in the array is empty, we can just do field, pick from that the position, and this is the wrong way around. And then see if that matches an empty character. The empty we defined above here. If that's the case, then it's a valid move, and the field will be changed with an under, which is very handy for modifying positions in an array, where we pick from move. We need to bind that because this needs to become a function. And we need some parentheses because these modifiers run from left to right. So this would bind to move first, but we don't want that. We want this to bind to each other. And then this will change to the computer character. So this is just a string or a character, but it'll act as a function here, which modifies it to the character, which modifies the value to the computer character. And after that, we're going to just delay for a second and then move on to player move. But in the case that the move wasn't valid, we want to go to the computer move again. So this is just recursion. We're going back to the computer move, and because it's printed immediately, you don't really see that it's going back over itself, and it'll just do the same logic again. Yeah, we can remove this, and we need to define the player move. And just do nothing here so they get stuck there. Test that. Hello, we're gonna play Tic Tac Toe, and then we get an error because there's no reverse for this because, oh, okay. I'm binding the wrong way. I need to bind it to this and then run it. No header matched argument. Oh yeah, and I need to return the same thing here. Player move. Otherwise it returns an add, and there's no add in the header. Yeah, so now it's just gonna run the player move constantly. We want to, of course, show the field here for a second. Print field, and then do this delay, and then go on to player move. Yeah, there's his move. It filled it up. Because I still have this computer thing there. I need it to be empty. So this is the first move of the computer, and then we go on to player move. This now all works. That's perfect. Let's enable the reset again, so we get a clean screen each time. And then we want to go into player move. For this, we want to get some inputs from the player. We wrote the function getChar with keys. That's this function. We store the result in the direction. So if you remember, we get back this array where the index of this matches up, where you get a 1 at the position of the matching string. That makes sense. So we get the keys, but we also want the character E, which we use to confirm. And we want to, instead of assign a 1 value to it, assign it to some values we can actually use. For moving, we can do that with slash, which gives us the index that is active. And we can just pick the first one that's active, because we always get a value from getChar. And what we can do is store this value first, so active index. Use this value to pick from a new array with values we actually want. So the keys we can change to vectors, which we can use to move a cursor around on the grid. So that's 1, 0, 0, 1, -1, 0, 0, -1. These are vectors to change the position. And for the last value, if it's E, then we can just give it E back so we can match on that. So now if we were to show this, it's going to go to player move, and if I do a character, you can see I get these vector arrays back, and if I press E, you just get the character E. This value we can store. File is a bit abstract, or actually we can just give this straight to a function. And in this function we can use header matching again to, for example, match on E, which means we want to confirm. And we can also match on these vectors, but here we just call it a direction, for example. And because it's just a name, it will match anything that's not E on there. If it's a direction, we actually want a variable which I call cursor, which is the position where you're selecting as a player. This just starts at 0, 0. If we're getting a direction, you want to update this cursor with the direction, so plus direction, let's do it like this. So this is a function which will add the value to which will add direction to the value, and we also want to modulate it around the size of the field, so that if you run over the side, then it goes back to the left again. That should work. And we also want to print at the player move our grid with the cursor on top of it. So we print the field, but we change the field on the position of the cursor. Oh yeah, field needs to be here. With a character which is like a selector, and I like the rotate character for that. It's sort of a selector character. So we're printing the field, but the position of the cursor is modified to this thing, which will give us, oh yeah, and we need the semicolon here. Okay. Oh, and this needs to be function with an S. Oh, I wrote this wrong, cursor. Yeah, so we're getting the same thing. And now it's printing this cursor here. And if I press the characters, it's going to move it. Okay, so now we can normally move the cursor. And we also want to clear this screen, reset the screen each time we print this again. Yeah, so that's perfect. I can now move the cursor around. But we need to give some functionality to E to confirm our position. With E, we want to check again if the space is empty. We can just steal it, so this functionality. Write a function which checks if the position of the cursor on the field is empty. If that's the case, then we're going to confirm our move, so we can also steal that. The field is updated with the player character on the cursor position, and we're going to print this field with the delay of 1, and then we're going to go back to computer move. So if I press E, then as you can see, my key is added there. The reason I'm not going to computer move is normally this should be the last thing that's returned, but I typed player move here, so then player move will always be returned. Now this function returns a string, which is the string that the while loop gets to get to the new state. So this goes back to player move because we're just updating the cursor position, but we're still busy with the player move. This goes to computer move, but we also want this case where the field wasn't empty, which is just going back to player move. So now I can place my thing there, and then the computer is going to make a move. And I can also place it on top of something I already did, but then it isn't empty, it will just do nothing. Yeah, and now all we need to do is to see who won, because now we don't do any checking of the field. And this we just do when a move is done. So for example, here the field is changed, and before we go to the player, we're going to check these things, which is player 1 field. Put the player 1 on the field. We want to go to a state player 1. We also need to check if it's full. I didn't write that yet, so let's write that quickly. Full is just taking the field and de-shaping it. If we would give this just a 3x3 array filled with ones, so this array, and de-shape it, you get just a list. And we want to see if all of them, this end fold, are true, and then we get if it's full or not. So this will take the field. So if the player 1, then we go to the player 1 state. Otherwise, if full field, if the field is full, then we go to the field full state. And otherwise, we just continue on to computer move. Okay. So I made a move. I'm going to check if I won. If that's not the case, then I'm going to check if the field is full. If that's not the case, then I'm just going to go to the computer. But if it was full, I'm going to go to the field full. Let's write it like that. And if I won, I'm just going to go to the won state. And I'm going to steal this logic for the player move. We want to know if the computer won. Then we're going to go to the computer won state. We want to know if the field is field, and go to the field full. Otherwise, go to player move. Yeah, and in this case, when we go to the player move, we want to do this stuff. So that's just our normal behavior. I always find it a bit hard to type these things nicely, the blocks, because they have lots of tabs. It's hard to, I don't really know the best way to compose them, but for now it looks like this. So this block returns the next move, and in here, in this block, this returns the next move, and then here we have these things. So maybe write it like this, so each comma is a new block. Yeah, that's maybe the best way to do it. And here again, we don't want to print the field there, but want to only print the field in this case. Okay, lastly, we want to write these new states. So we have player 1, which is going to go to end. We have computer 1, which is going to go to end. And we have field full, which is going to go to end. And we'll just print the small message like, yes, you won, congrats, yeah. And computer, oh yeah, I need to print this, P. And then computer 1 is going to be print, oh no, you lost the computer 1. And field full is just going to be the field was full. It's a tie. Nice, nice. This should work, and it doesn't, because I need the semicolons here. Computer. Oh, I wrote computer. It needs to be computer. Yeah. So there's the computer move, and then it's my move. I can choose a spot if it's empty, and then the computer makes a move, I can make a spot, and then, oh yeah, I do this, yes, you won, congrats, amazing. Let's make a small little tweak, print this with a small delay of 0.1 seconds, just so it's a bit nicer, and here where we have player move, I'm gonna print move the cursor with arrow keys and confirm with E. So then you can have some information on how to, here's my move cursor with the arrow keys, confirm with E. Let's do it like that, and confirm with E. Yeah, a bit nicer, not perfect. So we can move, make our selection. Let's go for the diagonal. So the computer isn't smart at all. That's a good challenge to do, to make it smarter. Oh yeah, let's print the field. Sorry, some small things. We said print the field, and congrats. Let's do the same here. Sorry, apparently my camera died. Here I am again with another camera. So I guess that's it, I guess. If we now win, let's try to win. Yes, you won, and then you see the field. That's it, I guess. It would be cool if the computer actually got smart, and maybe if you have a visualization where you can see the arrow, the line that won, or if there's a way to print this in a nicer way. There are lots of things to make better, but it's the basis is here, and I think there are some cool challenges, like the state machine here, and figuring out these, seeing if there is a line matching or diagonal matching, and the terminal stuff. Quite some cool stuff to have learned. Thanks a lot for watching. Till the next one.